Hello everyone, Jain to all. Welcome in Digital School of Ajay Kumar Garg Engineering College, Ghaziabad. In this video lecture, I am going to discuss about the basic concepts of graph. First topic is graph terminology. Before discussing the graph terminology, I want to discuss what is meant by graph. Graph is the collection of node and vertices, and each vertices having some assigned value or each edge having some assigned value. That value is called weight of the edges. The weight may be negative or positive, but in this lecture, we have considered only a positive weight, and the weight must be a integer value. Now, I comes on graph terminology. Graph terminology means we have discussed the basic concepts of graph, in which we have discussed about path, we have discussed about closed path, simple path, cycle, connected path, and so on. The first one is path. A path can be defined as the sequence of nodes that are followed in order to reach some terminal nodes V from initial node U. That means we have number of nodes, and if we reach from a node U to V, then that is called a path. There is a number of nodes which is represented by a circle, and if we reach from a single vertex to number of vertices, then that is called path. Second point is closed path. Closed path means if a path will be called as a closed path if the initial node is same as terminal node. A path will be closed path if V0 equal to V1. That means if the initial and final vertices are same, then that path is called closed path. If we reach on the same point from where we have to start, then the path is called closed path. The second point is simple path. In case of simple path, if all the nodes of the graph are distinct with and except Vn equal to V0, then such path P is called as a simple path. That means there is no repetition of nodes. Means if we reach from a node to another node and the initial and final node are same, because this is the simple path, at that case we have to not repeat the number vertices in which the path is considered. Next one is a cycle. A cycle can be defined as the path which has no repeated edge or vertices except the first and last vertices. In the same case, in this cycle, there is no repetition of edges. But in case of simple path, there is no repetition of vertices except first and last vertices. That means if we start with a vertices V0 and after processing the vertices we reach on Vn, that means the V0 and Vn may be same, but between Vn and V0 there is no repetition of vertices. That is the case of simple path. In case of cycle, there is no repetition of edges. Next one is connected path. A connected path, a connected graph is the one in which some path exists between every two vertices U, V in V. There is no isolated nodes in connected graph. That means V is the set of vertices, and if there is a path exists between every pair of vertices, then the graph is called connected vertices. In this graph, we have no isolated vertices, isolated node or isolated vertices. We have only the vertices which are connected with the given vertices. Then the graph is called connected graph. We can also define this point with the help of degree. That means if a node having degree more than 0, then the graph is called connected graph. That means there is no a single node in a graph which degree is 0. The next point is a complete graph. A complete graph is one in which every node is connected with all the other nodes. A complete graph contains n into n minus 1 by 2 edges, where n is the number of nodes in the graph. If the graph having n nodes, then there are n into n minus 1 divided by 2 edges, where n is the number of nodes in the graph. This means a complete graph is connected with every node, and the graph is called a complete graph. The next point is weighted graph. In a weighted graph, each edge is assigned with some data such as length or weight. As in discuss previous slide, the weight must be a positive integer, and it is assigned on a edge of the graph, and that value is must be a positive integer. The weight of an edge E can be given as W of E, which must be a positive value, indicating the cost of traveling the edge. Weighted graph used in a networking, where we have to calculate a number of graphs like spanning tree, minimum spanning tree, which is so what is the cost to reach a single vertex to number of vertices in a minimum cost. This is shown in a given graph. A weighted graph is an important graph which is show the cost of traveling from one point to another point. Next one is a digraph. A digraph is a directed graph in which each edge of the graph is associated with some direction, and the traversing can be done only in the specified direction. That means if a graph having some value and we want to traverse the given graph, then we have to traverse in a particular direction, then the graph is called a digraph. Next one is loop. This is also important point in a graph. Loop, an edge that is associated with the similar endpoint, can be called as a loop. That means the starting and end point is the same vertices. That means if we have to construct a self vertices on which we have to construct a loop, then that graph is shown in a particular types of graph, and the graph is called a loop. In case of loop, the starting and end vertices are same. Next one is adjacent node. If two nodes U and V are connected via an edge E, then the node U and V are called as a neighbors or adjacent node. That means in case of neighbor, adjacent, the nodes is called adjacent node. If a node is U and the number of nodes is connected with U, V, W, X, Y, Z, then the X, Y, Z, U are called adjacent of the given nodes. By using adjacent nodes, we have to calculate or construct a matrix that is also called representation of a graph. Now the next point is a degree of a node. A degree of a node is the number of edges that can be connected with that node. A node with degree 0 is called isolated node. As we discussed earlier, degree of a node means number of edges that is connected with that node is called degree of that node. And degree of that node is most important point in the case of graph, because we have to calculate the degree by using the connected edges with that node. If a node having degree 0, that means that node is isolated with the given nodes. Now, the next point is graph representation. This is the most important point which is discussed in the graph representation. There are two methods which is used in representation of graph. The first one is sequential representation, in which we have to use array, and next one is linked representation, in which we have to use linked list. In sequential representation, we have to use a simple array that is called two-dimensional array in the form of matrix and represent the value according to the given graph. And in case of link representation, we have to create nodes, and each node having the value of weight as well as the value of next vertices in the given graph. By graph representation, we simply means that the technique to be used to store some graph into the computer memory. That means how the data is stored inside a main memory is called graph representation. A graph is a data structure that consists of set of vertices called nodes and edges. There are two ways to store graph into the computer memory. First one is sequential representation, that is also called adjacency matrix representation. And second one is linked list representation, that is also called adjacency list representation. Both methods are used frequently, but maximum cases we have to use linked list representation. In sequential representation, an adjacency list matrix is used to store the graph, whereas in a linked list representation, there is a use of adjacency list to store the graph. This is the basic technique which is used to represent the graph inside the main memory. The first one is sequential representation. In sequential representation, there is a use of adjacency matrix to represent the mapping between vertices and edges of the graph. We can construct a matrix in which the dimension of matrix is number of vertices. If in a graph there are 5 vertices, then we have to create 5 cross 5 matrices. We can use adjacency matrix to represent the undirected graph, directed graph, weighted directed graph, and weighted undirected graph. All types of graph we have to represent in sequential representation. There is a method which is used to put the value inside the matrix that says if adjacency Aij equal to W, it means that there is an edge exists from vertices I to vertices J with weight W. That means if there is an edge between vertices I to J and the weight of the vertices is W, then we have to retain in matrix the value of W. And entry Aij in the adjacency matrix represent of an undirected graph G will be 1 if the edge exists between Vi and Vj. That means if there is an edge between Vi to Vj, then we have to insert value 1, otherwise we have to mark 0. If an undirected graph G consists of n vertices, then the adjacency matrix for that graph is n cross n. That means there is the dimension of graph is according to number of vertices. We have to take number of vertices as a row and column. And this is also fixed. If there is a 5 vertices, then the matrix form in the representation is 5 cross 5. And the matrix A equal to Aij can be defined as. Here Aij equal to 1. This is the value which is inserted inside the matrix A. Aij equal to 1 if there is a path exists from Vi to Vj, otherwise Aij equal to 0. That means if here we have taken a example, if you want to reach A to D directly, then there is no path because this is a directed graph. So we have not reached A to D directly. In case of entry A to D, we have to mark as 0. And if we want to show the entry for A to B, we reach A to B directly. So we have to mark 1 in case of directed graph. The first representation is undirected graph. Here, this is the given graph. In this graph, there are 5 vertices, A, B, C, D, and E. We want to represent this graph in the form of adjacency matrix. First, we have to make one column for vertices and one row for vertices. First column is according to vertices A, B, C, D, and E. This vertices considered from the given graph, and we also mark the vertices on horizontal A, B, C, D, and E. This is the also vertices which is given in the graph. Now we want to make entry in the adjacent adjacency matrix, we consider the connection of vertices itself is 0. That means we make entry for A to A is 0. Here means A to A we mark 0. A to B, there is a path between A to B, we have to mark 1. That means if we check the path, we have only considered the adjacency or neighbors of that node. If the neighbors of A is B, then we have to mark 1, otherwise we have to mark 0. The value of A to B is 1, A to D is 1, and remaining entry is 0 because E is the not adjacent of A and C is also not the adjacent of A. So we have to mark 0. That means if we have to enter 1, then the node must be adjacent to that node, otherwise we have to mark 0. Now if A to B is 1 in case of undirected graph, then there is an entry for B to A also 1, B to B 0, B to C 1, because if there is a path between C to B, B to C, this is the B to C and B connected with C, and C is also the neighbor of B, so we have to mark 1. B to D, B to D is a path, so we have to mark 1. Then B to E, there is no direct path between B to E, so we have to mark 0. Now C to A, C to A, there is no direct path between C to A, we mark 0. C to B, there is a direct path between C to A, we have to mark 1. C to C 0, C to D 0, C to E 1, because C to 1 E is the adjacent, E is the adjacent of C. By using this method, we have to mark or construct adjacency matrix for undirected graph. In case of if the graph is directed, then we have also construct adjacency matrix according to similar way. But here we have consider the direction of the edges also. There are 5 vertices A, B, C, D and E. First column we have to make entry of the number of vertices A, B, C, D and E. Same entry on the horizontal, that means called rows A, B, C, D and E. Self, in case of A to A, B to B, C to C, we have to mark 0. Otherwise, you have to mark 1 or 0. If a direction or directed path from A to B, then we have to mark 1. Otherwise, we have to mark 0. A to B, there is a direction between A to B and a path, so we have to mark 1. A to C, there is no direct path from A to C. That means C is not adjacent of A, so we have to mark 0. Now A to D, a direct path between D to A but not A to D, so we have to mark 0. A to E, there is no direct path between A to E, so we have to mark 0. B to A path from A to B but no path to B to A, so we have to mark 0. B to B 0, B to C, there is a direct path between B to C, we have to mark 1. B to D 1 and B to E 0, and so on. We have to construct adjacency matrix in case of directed graph. The third example is weighted graph. In case of weighted graph, where we have to mark 1 for adjacent, at that place we have to enter the value of weight of the edge. In case of A to B, there is a 1 because there is a path between A and B. Now we have to enter the weight of this graph, and the weight is 4. Here we have to enter 4. And so on, we have to construct the adjacency matrix for the weighted graph. Next one is linked list representation. In case of linked list representation, an adjacency list is used in the linked list representation to store the graph in the computer memory. It is efficient terms of storage as we only have to store the value of for that edge. Let's see the adjacency list representation of an undirected graph. The first example is we want to store or represent an undirected graph inside the memory by using adjacency list. First, we have to construct a list according to the given vertices. In the given graph, there are 5 vertices A, B, C, D, and E. We have to list first A, B, C, D, and E. Now, the adjacents are neighbor of A is B. So, we have to connect A with B, and B having 2 parts. The first one is the vertices and second part is the link part. The link part contain the address of neighbors of B. The neighbor of B is C and D. The first we have to store D here, which is the neighbor of B. Here the neighbor of B is connected with D. But we also keep in mind what is the neighbor of A. Neighbor of A is B and D. So we have to connect A with only B and D. So that we have to connect A with B, and B contain the address of neighbors of A, and that node is D. According to this, now B, the neighbor of B is A, D, and C. We have to connect all 3 nodes with B. Sequence may be C, A, D, R, A, D, C, which can be changed. We have to connect first B with A, then A address part contain the address of D node, and the D link part is contain the address of node C. This all 3 nodes each the neighbors of B, A, D, and C. Now the neighbors of C is B and E. So we have to connect only B and E with C. Here B and here E, and so on. The neighbors of D is A, B, and E. We have to connect all 3 nodes with D. And the neighbors of E is D and C. We have to connect D and C with E. This is the list representation of undirected graph. In case of directed graph, same process we have to use. But if the neighbors of A is B, but we can't consider D because the direction D to A, not A to D. If the direction is A to D, then we have to consider D as a neighbors. So A connected with only B. The neighbors of B is D and C only, not A. So we have to connect C and D with B. And the neighbor of C is only E. So we have to connect C with E. The neighbors of D only A. So we have to connect D with A. And the neighbors of E is D only. So we have to connect D only. There is no other nodes is connected with node E, because in case of directed we have to check only direction of the edges also. In case of weighted graph, the node is divided into 3 parts. The first part is contain the value of age. First part contain the vertices name, and last part contain the address of next node. Here there are 5 vertices A, B, C, D, and E. The neighbors of A is B. So we have to connect A with B, and the weight of A to B is 5, and the last node there is no other neighbors of A, so we have to mark as null. In case of B, there are 2 neighbors B, and the neighbors is D and C. So C, and the weight of B to C is 2. Here we have to mark 2. Then the last part is contain the address of node D, and the weight of B to D is 8, and so on. We have to represent this weighted graph inside the adjacency list. In case of all the representation, we have to mention or we have to consider adjacency node for connection. If the node is not adjacent, then we have not connected directly with that graph. And if the node is adjacent, then we have to connect that node with the given value. The value may be weight or direction. This is the all over about the basic concepts of graph. If any doubt, comment inside the comment box. Thank you.